So, welcome back, students, to Rama Teaches You. Today, we are going to start the physics class 11th third chapter, which is motion in a plane. So, Drupad, in this chapter, we will focus mainly on our understanding on vectors. Okay, so basically, what is a vector? How do we represent various elements in vector form, and all that stuff? Okay, so that is the main discussion that we have to do today. And also, using these vectors, how so once you see what is vector. Vector is a mathematical concept which helps us to analyze the various physics terms. Okay, it helps us in analyzing various physics terms, which gives us an understanding of how we can basically split a certain quantity into simpler dimensional directions. Like, we how do we split velocity into the horizontal component or the vertical component and all the other stuff. Okay, so in today's class we are going to start with vectors. So we know what is a vector, Drupad? Okay, it is a quantity that has both magnitude and direction. So, what is the magnitude? Magnitude represents the physical strength or the physical quantity that it has, whereas direction is what it is the place where you are directing all that strength, all that quantity in a certain place. We call that direction. So, there are two types of quantities, right? There is a scalar quantity and there is a vector quantity. So basically, a scalar quantity is one that does not have any direction. You can simply add them, subtract them, multiply them, divide them without any problem, because they do not follow the directionality rules that are placed in vectors. Okay, so a scalar quantity is what? It is just a quantity that does not have any direction. So what are some of the examples of the scalar quantities? Some of the examples of scalar quantities are time, mass, okay, length, what else? Work done. Work done is also a scalar quantity, right? We learned that in class 9th. Work done is a scalar quantity. Energy is a scalar quantity, right? Power is a scalar quantity. All of these quantities are scalar in nature because they don't see, work done does not depend on how you landed in a certain place. It only depends on where you started, where you ended. That's it, finished. It does not actually depend on the path of the object. Okay, how did the object move? What all did it do? What all did it have to overcome to reach this particular point? So basically, work done is not a vector quantity. But a force, we also learned this in ninth class, right? Force is a vector quantity. Why? Because it depends on where the force is actually acting on, right? For example, if I place a force of 10 newtons in this direction, right? Where will the table move? It will table move in the other direction, right? In the direction basically towards the direction of the force. But if there are two forces, if there are two forces acting on it, one is acting on this direction like this and the other is acting on the other direction like this, then there is a directionality in it, right? Basically, the force that has a higher magnitude will basically win, and the resultant force will be acted on in the direction of the higher force. Okay, so basically, if there is 10 newtons of force being applied from the left and 20 newtons of force being applied from the right, then we can say that the resultant 10 newton force is being applied on the table, because 20 minus 10 is 10. So the table will move by towards the right by a force of 10 newtons. Okay, so that is directionality. So directionality matters in the case of vector quantities. Now, vector quantities can be added and subtracted using the parallelogram or the triangular law of addition and subtraction. Okay, now in this book we are going to represent vectors either as bold letters or letters with arrows on top. Okay, you can either have bold letters or you will have arrows at the top. Okay, both of them represent vector quantities, right? Okay, next, the length of a line. Okay, now what is some what how do you represent a vector? A vector is like a ray. Do you know what a ray is, Drupad? What is a ray? Yeah, exactly. It has a starting location and it keeps on going like this. This is what a vector actually looks like. It has a tail end and a head, a tail and a head. So the direction of this arrow represents the direction of the vector. The direction of the arrow represents the direction of the vector. Okay. Now, the also the length of the vector, the physical length of the vector represents the magnitude of the vector. For example, if this is A vector, this is B vector, this is C vector, and this is D vector, then we can clearly see that D has the longest tail, right? So D has the longest tail. So if a vector has a very long tail, then we say that its magnitude is also very, very high, right? So D vector's magnitude will be greater than C vector's magnitude, will be greater than B vector's magnitude, and will be greater than A vector's magnitude. Okay, so the modulus sign that I'm putting in these letters in is called the magnitude of the vector. Okay, so the length, the physical length of the vector is actually representing the magnitude of the vector. Okay, the next part. Okay, now there are two types of vectors can be broadly classified into two different types. You have a polar vector and a axial vector. Now, what is the difference between a polar vector and an axial vector? A polar vector has poles. It has starting and finishing ends, right? You know where the vector started, you know where the vector is pointing, and you will know where the vector ends, if it ends in the first place. Okay, for example, in a polar vector you have poles. Okay, like you have a north pole and a south pole, you know the beginning and the end. Okay, similarly, a polar vector, for example, force, displacement, all of these are polar vectors. You have a starting point or a point of application are called a polar vector. Now, this is an example of a polar vector. There is an object like this, there is an object of mass m onto which a force of 10 newtons is being applied. Now, you can see that the force originated from which side? It originated from the left and it is moving towards the right. And this length of this vector is representing the magnitude of the vector. It has a starting point. It has a starting point, and that is the reason why it is called a polar vector. Okay, now what is an axial vector? An axial vector does not have a beginning or an end. It just represents a circular pathway. Okay, for example, an axial vector will tell you whether you are spinning in a clockwise direction or an anti-clockwise direction. Okay, it will tell you whether you are spinning in a clockwise direction or an anti-clockwise direction. Now, Deepak, do you remember the right hand rule? The right hand thumb rule? Yeah. Okay, now this vector addition actually came from here. The torque, the basically the current, the force due to the current due to the force, all of these were the beginning stages of what? They were the beginning stages of axial vectors. They were trying to represent the axial vectors at that point. Okay, they were all trying to represent axial vectors. Now look at this. If your vector is rotating in an anti-clockwise direction, look at this. So this is an anti-clockwise direction. Yeah, if your vector is rotating in an anti-clockwise direction, then the resultant vector will be upwards. Okay, it will be upwards. But if the vector is rotating in a clockwise direction, okay, if it is rotating in a clockwise direction, the thumb actually points where the vector is lying and it is downwards. Understood? Okay, so this is what an axial vector looks like. Now, look at this. There is no starting point. There is no starting point to either of these two vectors, right? No starting point at all. So that is a major difference between a polar vector and an axial vector. Okay. Next, some important definitions related to vectors. Okay, now before that, I have already told you this. The magnitude of a vector is often called the absolute value. Okay, so basically the overall strength of the vector. Okay, the numerical value of the vector. The overall numerical value of the vector is also known as the absolute value of the vector, and it is indicated by modulus of V. Okay, this bold letter is indicating the vector. So basically, if you want to write a vector, you will write it like this. Okay, if A represents a vector, then the magnitude of A is represented like this inside a square bracket. Sorry, inside a modulus, not a square bracket. I'm so sorry. Inside a modulus. Okay. Next. So the physical quantities which have no specified direction and have different values in different directions are known as tensors. Okay, so this is an MCQ based question. Okay, where basically you don't have a specific direction. Okay, and or every single direction you go, you have a different value of magnitude. So that value is called a tensor. Okay, now stress, moment of inertia, surface tension, pressure, all of these are examples of tensor. Okay, now basically in gaming industry they use these game physics, right? Okay, and I think I have heard that in those videos or something like that. Okay, now important definitions related to vectors. The modulus of a vector. What does the modulus of a vector represent? The modulus of a vector represents the magnitude of a vector. It represents the actual number value of that vector. Okay, next. Now, a unit vector. This is the most important vector in our whole story. Okay, if you can understand unit vectors, it will be a huge boon for you. Now, what is a unit vector? A unit vector, first I will tell you what its job is. A unit vector job is to just point. Okay, if it is, it's the whole job is to just point at a particular direction. Okay, that's the job of a unit vector. Okay, that's the job of a unit vector. It does not have a it only has a unit magnitude. You know what that one unit is? Unit is 1. If you have a magnitude of 1 and your job is to just point towards the direction, you are called a unit vector. Okay, so basically, why are you called a unit vector? Because if I write a unit vector next to a magnitude, I get an actual vector. Because if the magnitude is 1, right, if I multiply it by 10, it will become 10 unit, right? So basically a unit vector's job is to represent the direction of a vector. Now, how do you get a unit vector? Now we know that a vector is a culmination of what? Magnitude and direction. Okay, so I can write a vector as magnitude of a vector dot the unit vector is represented by a cap. Okay, this cap on top of a letter is representing the unit vector. Okay, now the unit vector becomes equal to what? Upon. So if you remove the magnitude from a vector, you get a unit vector. Okay, since a vector is made up of only magnitude and direction, if I remove the magnitude from the vector, I get only direction. Okay, and I get a direction having a magnitude equal to 1. That is why we call it a unit vector. So unit vector's job is to only represent the direction of a vector. Understood? And what is the formula for a unit vector? The formula for a unit vector is vector upon magnitude. Okay, this is known as a cap. Is this understood, Drupad? Yes. Okay, next. Then you have, okay, here, okay, now when we represent a vector, okay, we represent it in a reference frame, right? Okay, you cannot simply draw a line in space. You need a reference point, a framework in which all these calculations can be done. And that framework that we use is known as a Cartesian coordinate system. Okay, so we are going to use the x, the y, and the z axis to represent our various vectors. So the name of the chapter is motion in a plane. Okay, so motion, a plane is what? only the x and the y axis. Only two-dimensional calculations are to be studied. But for understanding vectors, we are going to understand the three-dimensional world of vectors. Okay, so we are going to have three axes, that is the x, the y, and the z axis. Okay, so the vector can be represented in the following three axes, right? Now, when you have a vector like this, okay, the x, the y, and the z axis has to be represented by a unit vector. Okay, so a unit vector is what is the job of a unit vector, Drupad? What is the job of a unit vector? To show the direction. That's it. Okay, the job of a unit vector is to show the direction. And in the Cartesian coordinate system, how many directions, what are the three major important axes that we have? The x, the y, and the z. We have allotted a unit vector for the x-axis, one for the y-axis, and one for the z-axis. Okay, we have allotted one unit vector for the x, for the y, and the z-axis respectively. The unit vector that we use for the x-axis is called I cap, represented by this value I cap. Okay, and the unit vector that is used for representing the y-axis is called the j cap, and the unit vector responsible for showing the z-axis is called the k cap. Okay, so if I say that I have a unit vector 3I cap, you know what that means? There is a magnitude of 3 units in the x-axis. 4j cap means you have a magnitude of 4 units in the y-axis. 7k cap means that you have a magnitude of 7 units in the z-axis. Okay, now before I proceed further, Drupad, let's go back to 10th class coordinate geometry. What does the point, this is the origin, this is the x-axis, and this is the y-axis. What does the point 2, 3 represent? What does the point 2, 3 represent? Drupad? So it is basically if you move 2 units in the x-axis and 3 units on the y-axis, you will reach the point 2, 3. Yeah. So basically this is the same way how we represent vectors also. For example, okay, if you have a vector 2I cap plus 3j cap, you know what that means? You move 3 units in the x direction and 2 units in the x direction and 3 units in the y direction to reach the same place. This and this are absolutely the same. Understood? This and this are absolutely the same. Are you able to yeah, if you understand this, please respond, okay, because I can't see your face, so basically it becomes very difficult for me to understand. So just nod, don't nod, just say yes or no. Okay, so 2, 3 can be represented as 2i plus 3j. Similarly, minus 2, 3 can be represented as minus 2i plus 3j, and minus 2, minus 3 can be represented as minus 2i minus 3j, and 2, minus 3 can be represented as 2i minus 3j. So these are the 4 ways in which we represent. Now if there is a z-axis also, like basically if there is a z-axis, you have a point 3, 4, 5, and that can be represented as 3i cap plus 4j cap plus 5k cap. That's it. This is how you represent a vector. by using the coordinates. Okay, so the more you understand this, the easier it will become. You have to put your maximum effort on vectors. If you do that, then the whole of physics could become easy. A lot of people still don't know how to solve vectors, how to resolve vectors in the x and the y axis. Okay, now next, the next topic is a null vector. Okay, what is a null vector? A null vector is a vector that does not have a magnitude. Okay, it's not like a unit vector. Unit vector has a magnitude. The magnitude of a unit vector is 1. The magnitude of a unit vector is 1. But for a null vector, the magnitude becomes 0. It doesn't matter which direction you're pointing on to. Since the magnitude is 0, it is worthless, it is useless, it is just a 0. Okay, so a null vector is a magnitude that has 0 value. Okay, you can have any arbitrary direction because it does not matter. Understood? It is very important that you know this. Okay, next, the equal vectors. What are equal vectors? Equal means what? A vector only has two things, a magnitude and a direction. If two vectors have the same magnitude and the same direction, you call them equal vectors. Now, Drupad, this is a very important term called equal vectors. You don't have to have the same starting point. Okay, there could be two vectors, A vector and B vector. You don't need to have the same starting point. If two vectors are parallel to each other, when you have two vectors parallel to each other, you know what that means? If two vectors are parallel to each other and both of them have the same arrow in one single straight direction, we say that there are equal vectors. Why? Because their magnitudes are both the same. See, look at this. The length is the same. The direction is also in the same way. So if you have equal magnitude and the same direction, then you say that these two vectors are equal vectors. Understood? Okay, so you have to understand this if you want to do parallelogram and triangular law of addition. Okay, it becomes easy for you. If there is any point you don't understand, you can ask me. Okay, please ask me. Understood? Till here, is there any doubt? Okay, Kana, no doubt. Okay, fine. Now, what is a negative vector? A negative vector is a vector whose direction is opposite to that of your vector. For example, look at this. You have a vector like this, 10 newtons, okay, in this direction. And you have another vector like this, again 10 newtons in this direction. Let us call this vector A vector and let us call this vector B vector, okay. These two vectors are not the same. You may say, oh, the magnitude is the same, but no, the direction is not the same. They are cancelling each other out. Imagine this, there is a table in front of you and I am trying to push the table with 10 newtons of force in this direction and someone else is trying to push the table with 10 newtons of force in this direction. Will the table move? The table will not move, right? The table will not move because both the forces have cancelled each other out, right? So that is what we call negative forces. Okay, negative vectors. Understood? So if basically there are two vectors having equal magnitude, if two vectors are wait, what? Okay, yeah, two vectors have equal magnitude but their direction is different, we call them negative vectors. Now, collinear vectors. What are collinear vectors? Vectors that are parallel to each other. Okay, so it doesn't matter whether the vector has basically a magnitude or not, doesn't matter. Okay, it could have any magnitude. These two vectors, okay, all these vectors are collinear vectors. Why? Because all these vectors are parallel to each other. Okay, two or more vectors are said to be collinear when they act along the same line or are parallel. Okay, they have to be parallel to each other. We call them collinear vectors. Okay, they have to be parallel to each other. Even these vectors are also called collinear vectors, both of them which act on the same line. Or you could have these vectors, okay, in the opposite direction in the same line. They are also called collinear vectors. They just have to be parallel to each other. Understood? They just have to be parallel to each other and you get a collinear vector. Okay, the next part. Now, what are A and B are collinear vectors. Look at this. All of these are examples of collinear vectors. Next, parallel vectors. Two collinear vectors having the same direction are called parallel vectors. Understood? Collinear vectors. You don't have to have the same magnitude. You don't have to have the same magnitude. All that is required is that you have the same direction. If you have the same direction, they become parallel vectors. Okay, and if you have the opposite direction, like if one vector is going in this direction and the other vector is going in this direction, both of them are opposite to each other, we call that anti-parallel vectors. Okay, we call that anti-parallel vectors. Understood? Okay, next, coplanar vectors. Now, Drupad, two vectors will always be in the same plane, whichever plane you choose. Two vectors will always be in the same plane. But you cannot say that about three vectors. Three vectors may or may not be in the same plane. Look at this, Drupad. So, this is a plane, okay? This is a plane surface and I have three pens. Okay, this is a plane surface and I have three pens. Now look at this. Okay, this is a plane surface. You have one vector like this. You have one vector like this. Yeah. So you have one vector like this. You have one vector like this, and you have one vector like this. All three of them are lying in one plane, like this. Okay, all three vectors are lying on the same plane. Oh my god, it just keeps falling. Okay, so basically now non-coplanar vectors will look like this. Like one vector is in the other direction compared to the rest. Okay, these are called non-coplanar vectors. Understood? Okay, next. Co-initial vectors. Co-initial vectors are those vectors that have the same starting point. Like this. Both A vector and B vector have the same starting point O. Okay, because they have the same starting point O, they are known as co-initial vectors. Clear? Now, orthogonal vectors. Now, look at this. Now, if you have two vectors that are perpendicular to each other, okay, if you have two vectors that are 90 degrees to each other, can you see this? If two vectors are 90 degrees to each other, we call them orthogonal vectors. Multiple vectors can exist in 90 degrees. Now, for example, you have this vector, and this vector. All three vectors are perpendicular to each other. Rupat, can you see this? So we can say that the unit vector I cap, the unit vector j cap, and the unit vector k cap, which represents the x, the y, and the z vectors, all three of them are orthogonal vectors. Exactly, orthogonal vectors. Understood? Yeah. Okay, next. Now, so if now I have already told you this, okay, like basically if you have a vector along the x-axis, you call it basically xi cap becomes a vector along the x-axis having a magnitude of x. Yj cap becomes a vector with a magnitude of y along the y-axis, and zk cap becomes a vector along the z-axis. Okay, localized vectors. Okay, now what are localized vectors? Now Drupad, if we localize. Localization means having a common reference point. If all the vectors in your plane, if all the vectors in your plane have the same, yeah, basically all of them share a same reference point. That is, for example, let's say you have one vector in the x-axis, one vector in the y-axis, one vector in the z-axis, one vector in the xy plane, one vector in the yz plane, one vector in the xz plane. All of them have somehow referenced themselves to the origin. They are all somehow related to the origin, right? Because they're all lying in the Cartesian plane, and the Cartesian plane has a center. We call that the origin. The 0, 0 and 0, that point is basically is acting as a representative for the distance, how far you are from one place, right? Okay, like for example, uh, I am localized to my room, right? Basically, I map everything from the main door of my house. Okay, how far is the kitchen? How far is the bathroom? How far is my study room? How far is my bedroom? All of that I have localized it from the main door. Okay, so the main door is like a reference point for all the other rooms, all the other spaces that is in my house. Okay, similarly, a localized vector will have a reference point, usually the origin, as the point across which all the vectors are localized. Okay, those are known as localized vectors. Non-localized vectors do not have a basically initial point. The velocity vector of a particle moving along a straight line. Okay, it is just simply this. Or a straight line move ஆயிருக்கு. Okay, it's moving in a random motion in a straight line. It is nowhere who knows where it is going, who knows how far it is from somewhere, nobody knows. So this is a non-localized vector. Okay, this is a non-localized vector. Did you understand this? Okay, now the next thing is we are going to understand what a position and a displacement vector mean. Okay, a position vector as well as a displacement vector. Now, a position vector is basically representing the position of a vector. Literal definition, it is representing the position of a vector with respect to the origin. Okay, now how, like basically if you have a point like this, right? If you have a point like this here, okay, now how far is this point from the origin? R. This vector, no, this vector, like this is O, this is A. Okay, this OA is representing the position vector. For example, this A can be any point. It can be 2, 5. It can be 2, 5, right? Now, this 2, 5 vector is in the first quadrant. So, therefore, R becomes equal to 2i cap plus 5j cap. So the 2i cap plus 5j cap represents the position of the point A. The position, this represents the position vector of the point A with respect to the origin. Similarly, you can have this point maybe B. This can be 5, 2. So this can be represented as R2. Okay, this R2 vector is representing the position of B, which is 5i cap plus 2j cap. This is called the position vector. How far is it from the origin? Understood? So these two vectors represent the position. Clear? Okay. Now the displacement vector. We can do the displacement vector from here on here itself. Now, what is the displacement between from point A and B? So AB can be represented as RAB. Now, be very mindful of what I have just written. AB. You know why I have written AB? Because the order matters in the vector. AB means what? You were initially at point A and now you are at point B. So your initial position was the A vector and the final position is the B vector. Similarly, RBA represents the initial point to be B and the final point to be A. So RAB is not equal to RBA. Understood? These are two different things. Understood? Drupad, like basically, For example, if I go to the supermarket and I'm coming back from the if I go to the supermarket, so basically my displacement will be from this point to that point. If I come back from the supermarket, my displacement will be in the backward direction. Both of them are not the same thing. Okay, they are actually negative. Exactly. They are negative vectors. Okay, these two are negative vectors. To make them equal, you have to say RAB is equal to minus RBA. These are negative vectors. Clear? Now, how do I find RAB? RAB means what? B minus A, right? B is the final position and A is the initial position. And from the definition of displacement, what we know that displacement is the shortest distance from the final position to the initial position, right? So RAB can be represented as R of the position vector of B. What is the position vector of B? I will just write it like this. It represents the position vector of B minus position vector of A. Now, let's look at the diagram. Who is representing the position vector of B, Drupad? R2. The position vector of B is represented by R2. Yeah, and the position vector of A is represented by R1. So I can write RAB is equal to R2 minus R1. To be more precise, you can write it as R of AB is equal to R of OB minus R of OA. That is the position vector of B minus the position vector of A. Similarly, R of BA can be represented as R of OA minus R of OB. Okay, now Drupad, what is the vector value of R2? 5i cap plus 2j cap and 2i cap plus 5j cap, right? Now, so this value R of AB can be written as R2 minus R1 is 5i minus 2j minus of 2i minus 5j. Okay, and when I open the bracket, I'll get 5i minus 2i minus 2j plus 5j. So this will become 3i plus 3j. This becomes the displacement vector. So R of AB can be written as this. Now vectors, usually when you add or subtract them, they follow the algebraic rule. Okay, look at this. Now look, when you have 2x plus 3y and 3x plus 2y, what do you do when you want to add both of them? What do you get? 5x plus 5y, right? So basically 3x plus 2y plus 2x plus 3y, you add the x with the x, you add y with the y, right? Similarly, here also you will do the same thing. You will add the I components together and you will add the y component, j components together. Okay, you are not going to add the I component with the j component and the j component with the I component. Okay, because you cannot do that. They are in two different directions. You cannot do that. They are representing two different values. Just like you cannot add 3x plus 4y, right? Can you add 3x plus 4y? You can add 3x plus 2x and 4y plus 6y, but you cannot add 3x plus 4y. Similarly, you can add I and I, j and j, but you cannot add I and j. Okay, understood this part? Okay. So this is called the position vector provides two information. It tells us about the minimum distance of an object from the origin. Am I right? 2i plus 3j and 3i plus 2j. Yeah, they are literally representing the distance, the minimum distance that the point is from the origin. It also tells us about the direction with respect to the origin. It also represents the direction with respect to the origin. For example, Drupad, okay, let's look at let's look at an example. You have a point 2 comma 5 and you have a point minus 2 comma 5, sorry, 2 comma minus 5. So this point and this point not only represent the distance, but this is telling that it is in the northeast direction, and this is representing the southeast direction. Okay, so its job is not only to tell you the magnitude, but it is also here to tell you what the directional values are. Am I right? Is it understood? Okay. Next. Okay. Now the displacement vector. What is the job of a displacement? We have just done this. Okay. We did this. The displacement vector basically tells us what the distance between the initial and the final point is going to be. What the distance between the initial and the final point is going to be. That is the job of a displacement vector. Clear? Okay. Now basically it is a straight line from the initial point and the final point and does not depend on the actual path undertaken by the object between these 2 points. Okay, now basically I told you if you have two position vectors, r1 is x1 I cap plus y1 j cap and r2 is x2 I cap plus y2 j cap, then the displacement r is given as r2 minus r1 is equal to, you subtract the I cap values with each other, you subtract the j cap values with each other, and then you get your result. Okay, you will get x2 minus x1 I cap plus y2 minus y1 j cap. Okay. Now Drupad, coming back to 10th class. Sorry. Do you remember the distance formula? Exactly, the whole square plus y2 minus y1 the whole square, right? And there was a special case for this when the x1 and the y1 values were 0. Yeah, so what was the formula? X squared plus y squared, right? Now Drupad, I have already told you that the position vector or a vector represents the distance from one place to the other, right? It represents the position. So similarly, if I say that a vector is a vector is equal to 2 I cap plus 4 j cap, right? Then the magnitude of a vector becomes 2 squared plus 4 squared is equal to 4 plus 16 is equal to root 20 is equal to 2 root 5. Okay, that's it. If you have I and j values, if you have I and j values in your vector, then the magnitude is simply the sum of the squares with the root of the sum of the squares, right? It is the root of the sum of the squares. Okay. Now we know that the displacement vector is given as what? X2 minus x1 the whole square I cap plus y2 minus y1 the whole square j cap, right? So the magnitude, if this is representing the a vector, okay, the displacement vector is written like this, then I can write the magnitude of a vector is equal to, for Drupad, again I'm reminding you, the magnitude has to be written inside modulus type signs. Okay, so this becomes what? Did you say something? Okay. So basically, since there is an I cap value and there is a j cap value, this can also be written as x2 minus x1 the whole square plus y2 minus y1 the whole square. This is what a modulus vector looks like. Is this clear? 100%? Okay, let's move on. Now, Multiplication of a vector by a real number or a scalar quantity. Okay, so Drupad, look at this. When you had 3x plus 4y, when you multiplied it by 2, what did you get? 6x plus 8y. It's as simple as that. If you are multiplying a vector by a scalar, a value that does not have any direction, the multiplication is pretty straightforward. Look at this. If you have 3i cap plus 5j cap and you want to multiply this by 3, what will you get? 9i cap plus 15j cap. That's it. Okay, so a multiplication vector by a scalar is a pretty straightforward multiplication. Okay, understood this point? Okay, next. Now, and yeah, so basically, now Drupad, one thing that you have to remember is if you are multiplying your vector by a negative value, for example, you have, let's say, 3i cap plus 4j cap is representing this vector that is going like this. Okay, I have not represented any axes. Okay, so don't worry about that. Okay, now if you want, I can make it simpler. So it is just 3i cap. Okay, 3i cap is representing a magnitude of 3 units in the horizontal x direction. Then if I multiply this by minus 1, what will I get? I will get minus 3i cap, and this will automatically change my direction. Instead of getting a value like this, I'll get a value like this. Clear? Yeah. Okay. Next. If we multiply a constant vector by time, we get a displacement vector in the direction of the velocity vector. You know what this is trying to say? This is trying to say that we know that velocity is equal to displacement upon time, and time is a scalar quantity. So if you multiply velocity with time, the velocity vector with time, you get the displacement vector. Okay, clear? Now, resultant vector. If there are multiple vectors, I'll start with this easy example. Okay, if there are multiple forces acting on an object, okay, if there are multiple forces acting on an object, let's say there is a force being acted on the object from the horizontal x direction, the negative x direction, the y direction, the negative y direction. Okay, the object has to move, right? It has to move. For example, Drupad, if there is a you are going in a mall, okay, you are shopping in a mall, you have that trolley with you. Okay, you have the trolley with you and you are just pushing the trolley in this direction. You are pushing the trolley in the forward direction. Understood? So right now there is a force being acted on the trolley in the forward direction, but some jerk or some idiot just pushes the trolley. Okay, he just pushes the trolley in this direction. So what happens? Will the trolley keep on moving forward? Will the trolley keep on moving in the same direction if he pushes your trolley? So in the horizontal direction, if someone pushes the trolley like this, okay, so if someone pushes the trolley like this, he just came and pushed the trolley. So will the question here is, you have not stopped pushing the trolley in the upward direction, in the forward direction, and someone just pushed the trolley like this. So where will the trolley go? Will it go this direction or this direction? Neither. It will go in this direction, because there is a horizontal component to this force being applied by you. There is a vertical component to this force being applied by this idiot. So basically the trolley, because of both these forces, will move in a diagonal way, will move with the combined forces in this way, and this is known as the resultant force. Okay, so if two vectors are acting at a certain at a certain point or on a certain object, the resultant vector represents the combined value of both the vectors. Understood? Okay, next. So if both the vectors are in the same direction, okay, for example, the trolley is really heavy. Okay, the trolley is really heavy, and instead of basically angering you, this guy also helps you push the trolley. Okay, this guy also helps you push the trolley, so both of you are applying a force on this trolley in the same direction. So therefore what happens to the trolley? Will it start accelerating? Yeah, it will basically, its velocity will increase, right? Because of both of you are putting a force in the same direction, therefore the trolley will start moving forward. So what happened? Both of your force, the resultant forces is a combination of both of your forces. For example, let's say you applied a force of F1 newtons and this person applied a force of F2 newtons, then F net is equal to F1 plus F2. So if there are two vectors acting on the same direction, like this is A and this is B, so you can combine these two vectors into one single vector called C, which has a magnitude of both A and B together. So C vector becomes equal to A vector plus B vector. Now, if you are trying to apply a force on a trolley like this, okay, and there is this person who is trying to put a force like this, both of you are like opposite to each other. He is applying a force of F1, you are trying to apply a force of F2, so the resultant vector becomes what? F resultant becomes F1 minus F2 if F1 is greater than F2, or F2 minus F1 if F2 is greater than F1. Okay, this is the result of these two vectors acting on the trolley at the same time. I hope this is clear. Yeah. Okay, the next point. Okay, now in the opposite direction, you get A plus B and A minus B respectively. Now, what will the magnitude be? You know how to get the magnitude. Okay, the magnitude becomes equal to any value, like basically the value which is greater. Now, Drupad, there is an important logic that you need to understand. Okay, there is a very important logic that you need to understand. That is, if all the vectors add up to, if all the vectors are added to each other and you come back to your original ideal location, then you can say that the sum of all the vectors is a null vector. For example, Drupad, there is a force being applied like this, there is a force being applied like this, and there is a force being applied like this. So you started from A, you went to B, you started from B, you went to C, but finally from C you came back to A. So these three vectors are having three different magnitudes. A, B and C, they are having three different magnitudes, but the direction is acted upon in such a way that all these, so is in such a way that the order, this is what the order looks like. Okay, starting from A you go to B, starting from B you go to C, and then from C you go to A. You have reached back to your original position, right? If such a type of vectors are there, then that is basically you have to remember the order. The arrows are very important. These arrows are very important. Now if you end up at the same location, you get the resultant vector as 0. Clear? The resultant vector becomes 0, and this can be applied on to anything. Like Drupad, you had a vector like this. Do you remember the displacement type of questions that we used to do in 9th class? You had a point A, you went to B, and from B you went back to A. What is the displacement? 0. Why? Because the initial and the final positions are the same. Now, if you have four vectors, if you have four vectors like this, one vector going from A to B, and then from B to C, from C to D, and back to A, then what happens? Again, the resultant vector becomes 0, and it can take any shapes like this. It can be n number of vectors. It can be n number of vectors. The only thing that matters is that is the sum equal to 0 or not. If the sum, sorry, are you coming back to the original location or not? That I'm sorry, I misspoke. Okay, are you coming back to your original location? If you are, then the resultant vector becomes 0. Understood? Clear? Next. Now, if you understand that, we'll move on to the two important concepts that we need to understand. Now, Drupad, see, look at this. If you, these vectors, when you add them up, no, Drupad, you have to remember the order. Okay, now again I'm telling you, AB vector is not the same as the BA vector. Both AB vector and BA vector are opposite to each other. Please remember that. Now, if you have a vector like this is how you represent it. OA plus AB plus BC plus CD plus DE plus DF plus FG plus GO. You are coming back to your original location. So your resultant vector becomes 0. Understood? Okay. Now, conditions for equilibrium of an object. Okay. Now, if what is equilibrium, Drupad? It is the balance point, right? It is the balance point. If all the vectors acting on a certain object cancel each other out, then you say that the object is in equilibrium. Right now, my weight is being cancelled by the normal force exerted by the ground in the upward direction. My weight is being acted on the surface in the downward direction, and the normal force experienced from the ground by me in the upward direction. That is the reason why I am not going through the floor or I am not floating in the air like a dummy. Understood? So I am at equilibrium right now. My position is in equilibrium right now. I'm not moving, right? I'm not moving. My position is in equilibrium because I am being balanced by my forces. Okay, so basically they are cancelling each other out. That's why my position remains the same. Clear? Now, there is no rotational motion of an object, that the torque due to the forces is 0. Now, I will explain this to you with the help of my trusty notebook. Okay, now Drupad, look, can you see this notebook? You don't have to see my face. Okay, face is not important. Just look at this notebook. Now, if I am applying a force like this and I'm applying a force like this, that is, both these forces are in the same direction, opposite to each other, this book will just squeeze. It will not rotate, right? It is trying to squeeze, but it will not rotate. But if I apply a force a little bit lower and apply this, the right forehand force a little bit higher, then now I'm going to apply a force. What happens? Did it rotate? I didn't do anything to it. I am not rotating the book. All I'm doing is putting a force like this and putting a force like this. And when I do that, it just rotates on its own. This is what torque is. Torque is the rotational force. Okay, you applied a force like this, you applied a force like this. Both of them are in the opposite direction, but they're not at level with each other. And if they're not at level with each other, then by applying a small force, you start turning. You start turning. And Rupat, I'm not turning it. I'm only applying the force. I'm only applying the force. If you have doubts, you can try this yourself at home. Okay, now. Okay, next. So the torque should be 0. For an object to be in equilibrium, for all its forces to add up to 0, the torque should also be 0. Is this point clear? Absolutely clear? Okay, next. Now, we are going to start the two methods Okay. Oh, there was one more point. There is a minimum potential energy of the object for stable equilibrium. For a stable equilibrium, you need to have minimum potential energy. Now, Drupad, where do you think the potential energy is higher? A pen being placed like this, or a pen placed on the ground? Whom do you think will have a higher potential energy? Both of them are stable. Both of them are not moving. They're not moving at all. I am the one who's moving them, but they're not moving. But once one pen which was on the floor did not fall because it was at a minimum potential energy. But this pen was on my hand for a while. But if I moved it violently, it just fell. You know why it fell? Because it was having an unstable equilibrium. It was having an unstable equilibrium. Understood? Okay, so for a stable equilibrium, an object needs to have a minimum potential energy. Okay, is this point clear? Okay, addition of vectors. Okay, Drupad, we are just going to take a 2 minutes break. Okay, I'll be back in 2 minutes. Yeah, so I'm back, and now we are going to start with the triangular law and the parallelogram law of addition. So, what are these two laws? What do these two laws represent, and why are they useful to us? So, what does the triangular law of triangular law of vector addition tell us? If two vectors can be represented both in magnitude and direction, one by the two sides of a triangle taken in the same order. Now, this is the most important line. Taken in the same order. Taken in the same order means what? If you have a vector like this and you have a vector like this, okay, these are two vectors in the same order. That is, the ending of one is the starting of the other. Then the third vector or the third side of the triangle represents the resultant of these two vectors in the order opposite to it. If this is the A vector, this is the B vector, and then this becomes the C vector, which is equal to A vector plus B vector. So this is called the resultant of the two vectors. Understood? This is called the parallelogram law of addition. Now, Drupad, look at this. Okay, let us look at with a question. Now, a boy travels 10 meters due north and then 7 meters due east. Find the displacement and the direction of the body. He went 10 meters north and 7 meters east. Okay, so basically these are the two displacements, that these are the two position vectors. Okay, then if we take them in order, then this represents what? Better? Is the whole screen visible? Okay. So these two vectors, okay, so basically this is the north side. He's going 10 meters north and 7 meters east. Then the resultant vector will look like this here. Okay, this is called the displacement, and the value of this becomes what? 10 squared plus 7 squared, because it's a right angle triangle. No, you can simply use a Pythagoras theorem to find the displacement. Understood? So the resultant vector will be in the northeast direction. Okay, it will be in the northeast direction. Now, basically, how do you accurately predict which angle will it be? How much angle will there be? This can be done by using the help of a trusty trigonometric ratio, which is the tan theta. So if you have a triangle like this, okay, and if this angle is your theta, then tan theta is known as opposite side upon adjacent side. So opposite side is what? Tan theta is equal to 7 upon 10, right? Theta becomes tan inverse 7 upon 10. For your this thing, you only need to write till here. Okay, then tan theta becomes 35 degrees. You don't have to remember the angle. You don't have to solve for the angle. You just have to write till here. Theta is equal to tan inverse 7 upon 10. Clear? Tan inverse, see, basically, look at this. If tan 30 degrees is equal to 1 upon root 3, right? Tan inverse 1 upon root 3 becomes 30 degrees. You cannot do this without using a calculator. You need a calculator in hand. Okay, so you only have to solve till here. That's it. Theta is tan inverse 7 upon 10. You use a calculator and then you figure out the final answer. Understood? Clear? Okay, now the next method is the parallelogram law of addition. If you can represent two vectors, as the adjacent sides of a parallelogram, if we can represent two vectors as the adjacent sides of a parallelogram, then we can basically complete this parallelogram, and the diagonal of this parallelogram represents what? The diagonal of a parallelogram represents the resultant of the two vectors. If this is A vector, this is B vector, then R vector is called A vector plus B vector. Understood? And now, triangular and parallelogram are the same thing. Okay, why do we have two methods to solve one problem? We have two methods to solve one problem because necessity dictates it. There are some questions where the triangular law of vector addition becomes more convenient. You don't have to move anything anywhere, and some places you can use the parallelogram law of vector addition. Now, the parallelogram law of vector addition is highly useful when you have co-initial vectors. Co-initial vectors means what? The vectors which have a starting location be the same. Then they are known as co-initial vectors. Clear? Okay, next. So, Drupad, you can convert a triangular into a parallel and a parallel into a triangular. Shall I show you how to convert a parallelogram into a triangle? All you have to do is, we know that if two vectors are in the same direction and their magnitude is the same, then they become what? Equal vectors. Okay, so if instead of having a vector like this, you take this vector and you keep it here like this. These two vectors are parallel to each other because the opposite sides of a parallelogram are parallel to each other. Right? Then this vector is the resultant. And look at this vector. This is A vector, this is B vector, and this is A vector plus B vector. Look at this. Look at them. Both of them have what? The same value. This is the diagonal. This is the third side in the triangle, and this is the diagonal in the parallelogram. Both of them are the same. Depending upon the usage, you can either use a triangular form of vector addition or a parallelogram form of vector addition. Both of them will give you the same result. Okay. A boy is simultaneously giving two velocities of 30 meters per second due east, that is 30 meters per second due east, and 40 meters per second due north. Okay, 40 meters per second due north simultaneously. Simultaneously means what? It has a initial point, right? They are co-initial vectors. Simultaneously he is doing that. Then you just have to complete this. When you complete this, what do you get? Not a parallelogram but a rectangle whose angle between the two angles is how much? 90 degrees, right? Okay, so this value, yeah, that is exactly, this is 40, right? He said 40 meters per second. So this becomes 50 meters per second because 30, 40 and 50 are what? They are Pythagorean triplets. Exactly. So this magnitude will become 50 meters per second. Understood? And what is the value of the tan? What is the value? So basically this was the question, right? And this was the angle. Now you can take this as theta and you can say that the value of theta is what? This is 40 and this is 30. Therefore tan inverse 40 upon 30 is equal to tan inverse 4 upon 3 is equal to theta. This becomes theta. Okay, you can use a calculator to find the value. Okay, you just have to stop till here. That's it. Understood? Yes, sir. Okay, next. Now, this law states that polygon law of vector addition. How do you do a polygon law of vector addition? For example, Drupad, look at this. You have a vector like this, 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 and then you have a vector like this. Okay. Now, Drupad, you can apply you just have to split this whole polygon. First of all, this is what the value of the magnitude is going to be. I know, but what is the resultant vector going to be? Just take a starting point. Okay, now Drupad, if this is the A vector, this is the B vector, this represents A plus B vector. This is the A plus B vector, this is the C vector. This represents the A vector plus B vector plus C vector. And if this is the D vector, then therefore this represents what? A vector plus B vector plus C vector plus D vector, and lucky for us, A vector plus B vector plus C vector plus D vector is bringing us back to the original A value. Therefore, we can say that A vector plus B vector plus C vector plus D vector is equal to 0. This is how you solve a polygon. Okay, a polygon is nothing but multiple triangles. You can make multiple triangles of it. You can also do this. Look at this. If you have 4 vectors like this, okay, if you have 4 vectors like this, you have a vector like this, you have a vector like this, you have a vector like this, and you have a vector like this, all you have to do is this. So this is A vector, this is B vector, this is A plus B vector. So B vector, this is C vector, this becomes A plus B plus C vector. And here also you're coming back to your original location. So you will get A vector plus B vector plus C vector is equal to 0. Understood? So this is called the parallelogram law of vector addition. Understood? Next part. Yeah, like polygon. Sorry, I'm so sorry. I said parallelogram, right? I was supposed to say the polygon law of vector addition. I'm sorry. Next, properties of vector addition. They follow the commutative law. A plus B is B plus A. Okay, doesn't matter how you start. For example, look at this, Rupert. This is A, this is B. A vector plus B vector gives you the C vector. And look at this. This is the B vector. Okay, both of them are the same. They are parallel to each other. This is the A vector. So B vector plus A vector gives you the C vector. These two are parallel. This is also the C vector. This is also the C vector. So basically, they follow the commutative logic. They follow the commutative logic. Similarly, A plus B plus C is same as A plus B plus C. So they follow the associative logic also. And they also obey the distributive law. That is, if you multiply a scalar with the sum of two vectors, both these vectors will become lambda A plus lambda B. For example, if you have two vectors, A vector plus B vector, the whole multiplied by 2, you get 2A vector plus 2B vector. You know how you can show this? You can show this like this. If this is A vector and this is B vector, then this will become A vector plus B vector. So if you have 2A vector like this, and this is 2B vector, 2A vector, and this is 2B vector, this becomes 2a vector plus 2b vector. So basically this follows the distributive logic 2. Clear? Now look at this, Drupal. A particle has a displacement of 12 meters due east. Okay, and 5 meters due north, and then 6 meters vertically upwards. Vertically upwards means this. It's not north, it's vertically upwards. Okay, so what is the resultant going to be? The resultant is going to be a value like this. Okay, vertically upwards looks like this. It's not vertically upwards like this. It is very difficult to draw this in a 2 dimension. That is why they have screwed up this diagram. Okay, so it is like going like this and this vertically upwards, and this is the resultant vector. Okay, and basically how do you solve the resultant vector? We know that this is how much, this is 12 and this is 5, so this will become 13. And if this is 13 and this is how much, 6, 6, 13 and 6 6 are 36 plus 13 13 are 169. 36 plus 69 is how much? 60 30 90 202, right? Yeah, sorry, 205. So 205. So this vector, okay, this vector, can you see my hand? This vector like this. Okay, this vector becomes my, look at this, this vector, I'm showing it to you like this. Okay, this vector becomes equal to, the magnitude of this vector becomes 205, which is 14.3. Clear? This is how you add two vectors. Understood? Next, you have the subtraction of two vectors, the graphical method. How much? Okay. Dhruvat, can we continue this in the next class? Yeah. So the subtraction vectors and the dot product and the cross product, we can finish this up in the next video. Okay. So see you in the next video. Thank you. Bye. Okay.